Today we're going to be talking about one of my favorite topics, probability. So we're going to do both theoretical and experimental probability. You probably have an idea that probability just tells you how likely something is to occur. We're going to be dealing with rolling a dice a few times just in my examples as I talk to you here. So how likely, the chance that something has to happen. An outcome is the result of a single trial. So if I roll this dice right up here, right now my outcome was 3. On that time when I rolled it, I got a 3. That was my outcome. The sample space, that's the set of all possible outcomes, so all the numbers that I possibly could roll. So you can probably see this is just a normal dice. It just has the numbers 1 through 6. So my sample space, in this case, all the possible outcomes that would occur are the sets of 1, 2, 3, 4, 5, or 6. So my sample space, everything that could happen. Okay, an event is any single outcome or group of outcomes. So the event, the first thing that happened, I rolled a 3. Okay, that was the event of rolling a 3. I may say that, first I roll a 3 and then I roll a 1. That could be a group of outcomes that's happening. So any of the events that are happening. Okay, when we look at finding theoretical probability, I should probably not give you all this information at once. The theoretical probability, this is a formula that you can use if all the possible outcomes are equally likely to occur. So if everything that happens is equally likely, you can find theoretical probability just by saying, dividing the number of favorable outcomes, which is what you're looking for, by the number of possible outcomes, which is everything you could get. So in that dice rolling problem, if I was looking for getting a 3, for example, the number of favorable outcomes I would have would be 1 out of all the possible outcomes, which there are 6 of them. So the probability that I got a 3 would be 1/6, and 3 would be my event that would be happening. So we see P in parentheses an event that says the probability of that event occurring. That's how you read that in math. Okay, we can write probability either as a fraction, a decimal, or as a percent. It's going to be your choice unless I guide you onto which one I'm looking for. Probabilities range from 0 or 0%. That means they're impossible to happen. Okay, so like the probability that you turn into a frog tomorrow. Okay, that's probably going to be 0 or 0%. That's impossible. Or 1 or 100%. The probability that I roll a number on the dice. Okay, that's definitely going to happen. That's certain. Okay, that's 1 or 100%. They both mean, yep, that's 100%. That's definitely going to happen. Okay, compliments is probably a new vocab word for you. I'm not talking about like, hey, I'm giving you a compliment. You look really nice today. I'm talking about a compliment. That means everything that is not in the event. So complement of an event, everything that's not in the original event. So if my event is rolling a 3 on the dice, my complement would be rolling a 1, 2, 4, 5, or 6. Anything that's not in that event. So here's your first problem. Try it on your own. What is the complement of rolling an even number on a die? So in this case, I'm looking for everything that's not an even number. So I could say rolling an odd number on a die. Or I might say not rolling an even number on a die. Okay. What is the complement of the event that it rains today? Okay, everything that doesn't occur there. So it does not rain today. Be the complement here of that event. All right, if you add up the probability of an event occurring and you add up the probability that its complement will occur, you should always get 1 whole or 100%. So like the probability that I rolled a 3 on the dice was 1/6. The probability that I did not roll a 3 on the dice was 5/6. If I add 1/6 and 5/6, I get 6/6 or 100%, because that should be telling you everything that's possible to happen. So when you add up the probability of an event and its complement, you should always get 1 whole. Or you probably messed up on either the probability or the complement. Okay, let's try this problem. A bowl contains 12 slips of paper, each with a different name of the month. Find the theoretical probability, so in theory, that a slip selected at random from the bowl has a name of a month that ends with "burr." Try that on your own and then come and see if you get it right. So I'm just going to talk myself through the months: January, February, March, April, May, June, July, August. So far I'm not getting anything with burr. Okay, oh, but now it comes to September, October, November, December. Okay, so these all end with burr. I wonder if it's just because they're so cold. So here we go. We have 4 months that end with burr, and there are 12 slips of paper. So we can say 4/12. And obviously, if it's a fraction, I'd like you to reduce that to 1/3. If you feel the need to write it as a percent, 33 and 1/3%. 1/3 is totally fine. Okay, for a number cube, find the probability of not rolling a number divisible by 3. So we're looking for the complement of to a number divisible by 3. Everything else. Try this one on your own. Okay, now think about this. The numbers that are divisible by 3, 3 is divisible by 3. 6 is also divisible by 3. So there's 2 numbers that are divisible by 3, so everything else is not divisible by 3. So there should be 4 numbers that are not divisible by 3, namely 1, 2, 4, and 5. Okay, out of the 6 numbers, so the probability here of getting a number that's not divisible by 3 is 2/3. Or I could put 66 and 2/3%. Okay, that's fine. All right, odds, something you've heard of before, but I bet you don't know exactly how they work. Odds describe an event by comparing favorable and unfavorable outcomes. So say, I'll do something really simple here. Like, here are a few people in a class. I'll say the red people are girls and these black dots are boys. And I want to know, I want to compare the probability to the odds. So if I'm asking you the probability that I get a red dot here, the probability that I get a red dot, probability of red, I hope you notice that there are 3 reds out of 5 dots, so it's 3 out of 5. But if I ask you the odds in favor of red, what we do is we compare how many reds there are, everything you're looking for, to how many things are not red, everything you're not looking for. So the odds in favor of red are 3 to 2. And often we write this with the colon in between, or the word to. Okay. So the odds in favor of red, we're comparing favorable to unfavorable, so 3 to 2. Well, the probability of red is 3/5. The odds for red are 3 to 2. So I want you to notice that distinction. Okay, so here let's look at that number cube again. Find the odds in favor of a number cube landing on a multiple of 4. So we need to think, what are all the multiples of 4 on a number cube? Well, actually, in fact, there's only 4 in this case. So there's one thing that could happen in favor of it. Probability of 4 would be 1/6, but this time I'm asking for odds. So odds favorable to unfavorable. I could get unfavorable would be a 1, a 2, a 3, a 5, or a 6. So there are 5 outcomes that are unfavorable. So my odds in favor of getting a multiple of 4 are 1 to 5. 1 to 5. Okay, sometimes we also look at odds against. I'm going to ask you for the odds against picking a vowel from all the letters in the alphabet. So this time I'm just going to have you consider A, E, I, O, and U are vowels. We'll consider a Y a consonant this time. So I want to say, okay, how many vowels are there in our alphabet? There are 5 vowels. So vowels is 5. How many non-vowels or consonants are there? There's 26 letters in the alphabet, so there must be 21 non-vowels. This time I want the odds against it happening. So if I was saying the odds in favor, I'd say 5 to 21. The odds against are going to be 21 to 5. So this is going to be my final response here for my odds. Okay, experimental probability is when you actually do an experiment or something happens, like I did roll that dice before. It's probably based on data collected from repeated trials. So you do trials over and over again. And this, if it's experimental probability, the probability of the event happening is the number of times that the event occurs divided by the number of times the experiment is done. So like if you shoot a basketball 100 times and you make 63 of your free throws, your experimental probability was that you make 63 out of 100. Okay? All right, so here it is. A problem. Quality control inspected 500 belts at random. They found no defects in 485 belts. What's the probability that a belt selected at random will pass quality control? Okay, so we want to say how many times did this happen? No defects, that means they probably passed, was 485 out of the total of 500 trials. So 485 out of 500, and it would be a really good idea for me to reduce that. Okay, I could divide them by 5. I'm going to get 97 out of 100. So 97 out of 100 is okay. This one's a nice problem for a percent since it's already out of 100. 97% chance that this belt's going to pass quality control. And that's out of an experimental probability. Okay, so now we're going to go with that last answer, which remember we thought it was 97% likely that we were going to pass quality control. So it says, if the belt manufacturer from the previous example had 6,258 belts, predict how many of the belts are likely to have no defects so that they're going to pass quality control. So in this problem, try it on your own because we have done something like that this year. But then look back. Okay, so we are just really looking for 97% of that 6,258. So remember, if we do 97% of 6,258, you want to remember that in math, of means times, so I'm multiplying. And it's good if you change that 0.97 to a decimal. 0.97 times 6,258. So I'm going to go ahead and do that. Definitely use a calculator on that one. You're going to be allowed on this part of the quiz. I get this number of 6,070.26. Obviously, that doesn't make sense as for a number of belts. It's probably going to be a whole number for a number of belts. So I'm going to say about 6,070 belts will have no defects. Okay, so that's going to be a good answer there. All right, I want you to ask yourself a couple questions and see if you understand these things before you are done. Can you explain the difference between theoretical probability and experimental probability? Okay, so ask yourself if you know that difference. If not, it might be time to go back and review a little bit. And do you know the difference between odds and probability? So if I ask you the odds in favor of picking a girl or the probability of picking a girl in a group of 5 people where there's 2 girls or something like that, I want you to be able to explain that to me. If you can't, go back and review. And we'll see how you do with this. But I love probability. It's a lot of fun.